Today we're going to do activity 3. It says, how does a Genecon behave like a battery? A Genecon is a handheld generator. It looks like this. Okay, so it's this handheld generator. I have wires hooked to it, and they have the alligator clips on the end. There's a black one and a red one. So I can hook these up to a circuit, and then I can crank the handle and push charge. So I'm applying a force physically. So here's the first thing. They're wanting you to make predictions here first. I'm going to set up a circuit like this, and it only shows one battery in here. It says, how will the brightness of the bulbs in the 1-cell circuit compare to a 2-cell and a 3-cell? So I'm going to set this up with just 1 cell, 1 battery, and then I'm going to put 2 batteries in, then I'm going to put 3 batteries in with 2 bulbs. You need to tell me, how are the bulbs going to compare when they light? They're going to have the same brightness, more, less. The next thing is I'm going to put a compass needle underneath the wire for a 1 cell, then a 2 cell, then a 3 cell, and we're going to look at how does it deflect. So what would you guess? Is the needle compass going to deflect more, less, or the same for each circuit? And then the next one is, how will the number of turns in 10 seconds of the Genecon handle to match the bulb brightness in the 1-cell circuit compared to the 2-cell circuit and compared to the 3-cell circuit? So you need to put down what you predict, and then over here we're going to do these, and then you're going to record these. Okay? Now when I do the 1 cell, I'm going to look at bulb brightness. You need to look close, and then I'm going to do my compass deflection at that same time, and I'll tell you what it is. Then I'll add in another battery, hook up the circuit, and do it again. And then I'm going to do this last part right here, so we've got to kind of recall how bright the bulbs looked, and then crank the handle for 10 seconds, and I'm going to do it 3 times, and then you can do an average to see, hey, how many cranking of the handles do I need? Okay, so we're going to start with the 1 cell. So I have 1 cell in here right now, and I've got my 2 bulbs here, and I'm going to put my compass needle here too, and I will tell you how it deflects and how much it deflects, because I'm going to do this at the same time. So I'm going to set this up. I need to get this here. You might not be able to see that. So if I do this, the needle went this way. It went counterclockwise, and it looks like it deflected about 10 degrees. Okay, let's look at that. Did those bulbs light up? I just barely see in this one right here. I just barely see. There's a little dim light in there, not much. I see just a little dim light in that one too. It's just glowing. Okay, so that's 1 battery. Now I'm going to put in a 2nd battery, the 2nd cell. I'm going to do the same thing. Set the compass up here just like we did before. This is going to go in here, and check this out. Oh, bulbs are definitely brighter. Looks like the compass needle deflected again, and the same way, but it went about 20 degrees. Okay, so you can see the bulb brightness. I'm going to go to 3 bulbs, or 3 batteries, 3 cells. I'm going to do the same thing. See how that compass needle deflects, and look at the brightness of the bulb. Compass needle deflected in the same direction, and it looks like it was about 30 degrees. Okay, so that's telling us as we keep adding a cell in here, it must be causing more charge to flow, and then when more charge flows, we could see the bulbs got brighter. Okay, so we saw how bright those bulbs were. They weren't very bright at all to begin with. I'm going to hook my Genecon in here. So this is my handheld generator. So it has the alligator clips on it, just like we had before. So this is hooked right in my circuit with my bulbs. Okay, so I want to watch the clock here for 10 seconds, and I want to make these bulbs. I'm just going to do a practice. I need to just barely make these bulbs light up. I'm cranking the handle. Oh, there they go. In class, I need to get this. They just need to just barely light up. Here I go, 10 seconds. 1, 2, 3, 4, 5, 6, 7. 7 for my first one. I'm going to do it 3 times. 1, 2, 8. I got 8 cranks on that one, and I'm going to do it a 3rd time to make those bulbs just barely light. 9. Okay, so that was 9. Now, I want the bulbs to be brighter like they were in the second round when we had 2 batteries in there. I'm going to do the handheld generator again. Watch my clock for 10 seconds and make them brighter. And about like that. 1. Got 11. Another 10 seconds. Make them. I got 11. And one more trial. I got 12. Okay. Now, the 3rd trial is to make them as bright as like 3 cells. I'd say 3 cells is something like this. So I'm going to start my timing now. 1, 2, 14. Here we go again. 15 for the second trial, and one more time. So what this is showing us is this force of me cranking this pushes charge, and that charge is all over, and so this plugs in, all this metal piece, that charge is all over in this wire, and that's all I'm doing is making the charge push. Okay, and I make it go. So that's what the battery does, is it pushes charge too, except it does it by a chemical that's in here. This is me pushing this. You know, if I unhook this, and I crank this now, this cranks so easy because this is not connected to anything. I'm not pushing any charge. When I have it not connected to anything, I'm not pushing any charge. Once I start connecting it into a circuit, I'm pushing all that charge that's in here and all of the conductors. It gets more difficult to push. Okay? So we call this a Genecon. It is just a handheld generator. That's all it is. It's just a generator that's going to make charge move. So we need to look at a few notes here. So with this activity, a couple notes that we are going to take are going to be this. 1, we need to come up with our conclusion. So our conclusion could be, as we increase the number of batteries, doesn't that make the bulb brighter and the compass deflect more? That would be one conclusion that we definitely could see. Oops, my camera got bumped. So we can say as we increase remember, those cells are our batteries in a circuit. bulbs are brighter, and the compass deflects more. So we're talking about the compass needle, right? That's what we look at when we're looking at the compass. The compass needle will deflect more. So that's one thing we could see, because as we added more batteries, that happened. Using a Genecon. So a Genecon is a handheld generator. Turning the handle pushes charge. In a circuit. We also notice that turning the handle faster causes the bulbs to be brighter. Okay, so those are kind of two big pieces, and then there would be one more, and that would be a Genecon and a battery push charge in a circuit. So a Genecon and a battery push charge through a circuit. So what we're saying is that the charge is not being made by the battery. So many people believe it is. It is not. It is just, it's already in here. It's in all of the conducting materials. Anything that's a conductor has charge in it. Something just has to come along and push it. So that's what this activity is trying to get across, is that the charge, to make it mobile, it has to have a force to push it. And so the battery can act as that force. A Genecon, and this one is very physical because you have to crank it with your hand. You've got to apply a force that can push it. And so that's what we are trying to make you understand, is the charge is already in the circuit.